What's up, Vue community? This is Sarah Dayan speaking to you from France, from Paris, in my home office. And today I want to talk to you about finite state machines in Vue 3 with the composition API. So again, my name is Sarah Dayan. I work at Algolia. I'm a front-end engineer, and I love Vue. I've discovered Vue many years ago, and it blew my mind. So back then, I mostly used jQuery to build web applications. And so that was a revolution for me to be able to create declarative web applications fully driven by reactive states. Now, in all modern front-end libraries, state drives everything. Everything. You bind state to your templates and it drives the render. So when you mutate that data, the library updates the render. So that could be a string or a number that you use to display a dynamic label or compute a numeric value. It could be an array that you use to display lists or tables or objects to represent information about a given item. It could also be a Boolean to define visual state at a given moment. For example, think about a toggleable sidebar that could be open or closed. So a Boolean would be ideal to represent that. A classic example of state in action is when you are fetching data. As you start fetching, you want to notify the user with some loading indicator so that they know that something is coming. When the data arrives, you want to show that data. If there's an error, you need to let the user know. But in both cases, you want to remove the loading indicator. And this is how we leverage these values in a template. First, we are showing the loading indicator. If we have data, we want to show that data, so we loop over it. And finally, if we have an error, we want to show a message. But what happens when you have a logic error? For example, imagine that you forget to update the loading state after you assign the data. Inconsistent state, your app is broken, your customers are angry. So this is because imperative programming is more error prone. It is easy to forget steps or to make mistakes. We all moved from imperative JavaScript, DOM API, or jQuery to declarative Vue mainly because of the numerous pitfalls of imperative programming. We know we should only control the what, not the how. With Vue, we only control the applicative logic, and we let Vue take care of connecting it with the platform. Think with the DOM, that could be with a CLI, anything. But somehow we are still imperatively assigning states, like we used to manually mutate the DOM by hand. So why don't we use a better system, some kind of a framework that models the concept of state and lets us take care of the what and not the how? I'm not talking about a state manager or anything that centralizes and distributes state. What I'm talking about is some kind of an engine that helps us model state and ensure its integrity. Some sort of a state machine. The basic idea of a state machine is to represent all the finite states of a given object. So for example, a song can be playing, paused, or stopped. It can only be in one of those states at a given time. So you can transition between these states. For instance, you can toggle between playing and paused or between playing and stopped. You can also go from paused to stopped, but you cannot do it the other way around. To trigger transitions, we send events. So these are the basics of state machines. A list of finite states, always one at a time, which we change with transitions that we trigger with events. So this is an interesting model because it ensures state integrity. Instead of defining imperative UI flows and lose track of their logic, state machines make them first-class citizens by letting you model them declaratively. It also fits very well with the reactive nature of Vue. We can change the state of a machine and let Vue react to its changes. In JavaScript, the most popular finite state machine package is Xstate. Xstate was invented by David Khorshid and grew into quite a mature library over the years. Xstate ships with bindings for Vue, including for the composition API. So together, we are going to give it a test drive live by refactoring a working application that uses imperative state. Let's get to it. So this is the application that I've built with Vue 3 and the composition API, and that we are going to refactor today with xState. So this application contains a little bit of applicative states. You have, for example, the sidebar here that you can toggle like that. You also have this preview here that you can toggle as well. And you can switch between this view, the preview, and HTML view. Preview, HTML view. And right now, everything is handled manually. I'm going to show you right now in the code what that means. So this is the export function of my editor.vue file. So here you can see you have a bunch of composition functions to handle the application. And starting here, you have all the manual code to handle the applicative state. So the state itself is a reactive object. It contains the state for the sidebar, for the preview mode. And then you have a bunch of functions to mutate that state. Finally, we return everything here. This way we can use it in the template. For example, here we have the button to switch the sidebar, to toggle the sidebar. We are executing this toggle sidebar function. We are using the editor state as well to decide whether to show or hide stuff like the label here or the sidebar itself in that case. So this is nice, it works, but the problem is that this is all very manual. This is very error prone. As the application grows, I would need to create more functions. I could make the application enter conflicting states. So this is not something that you want to do manually. You want to use a system that is more robust and that is going to ensure that your application state is handled the way it should be, that it can never enter a conflicting state. So the first thing we're going to do is create the definition for our state machine. So we're going to create a new variable called editor. And we're going to use machine, which is a factory function that xState exposes, which takes an object, and we are going to define our states. So unlike what we have right now, where we have a Boolean that defines whether our sidebar is open or not, so that's a binary state. In xStates and with state machines, what you do is that you define all the different states that a machine can be in. And then the state machine ensures that it can only be in one state at a time. So in that case, we would say sidebar expanded and sidebar collapsed. So these are our two states. And now what we want to do is make sure that we can move from one to the other. So to do that, what you do is that you define transitions. Transitions are triggered by sending events on the machine. The machine listens to events, and depending on the state on which it is at a given time, it will move on to another state. So for example, when we are on sidebar expanded, we can define a transition. So on toggle sidebar, and it would go to sidebar collapsed. The same way, when we are on sidebar collapsed, we define the transition, toggle sidebar, the same one, and you would go to sidebar expanded. So right now we are reproducing that binary state that we had with the Boolean with those two states, and when they are receiving that same event, they would go from one to the other. Finally, because the machine has to be in one state, it cannot be in 0 states or 2 states, it has to be in one state, we are going to define an initial state. So in our case, we want the sidebar to be expanded by default. So we can say initial sidebar expanded, right? And so now that we have that machine, what we need is to create a running instance of it, what you call a service in X state. For that, you can use the composition function exposed by xstate called useMachine, and you pass your the machine definition, and it will return the state, which is an object we can use to see what the current state is, and send, which is a function which will allow us to send events. From that point on, we can expose state and send to our template, and now we can use them right away within the template. So here, instead of executing the function imperatively, we are going to send an event and let xstate manage the state switching. So we can do send toggle sidebar. And so the machine is going to receive the event and switch the state based on the state that it is on at a given moment. And so here we can refactor this line and this line. Instead of using our manual editor state, we can say, okay, in that case, we want to show or hide based on the current state of the machine. So we can say state matches, which is a method that will return a Boolean based on the state that I pass, and that would be sidebar collapsed in that case. And here that would be state matches sidebar expanded, right? So now we are done refactoring the sidebar, so we can remove the old code that we no longer use. So we no longer need this toggle sidebar here. We no longer need the definition here, and we no longer need that line. Now I'm going to save, and we're going to check in the browser if it works. Cool. I'm in the browser, and as you can see, it still works, so that's great. We just refactored the sidebar. So now let's move on to the preview. So in our state machine right now, we have those two states, and we want to also be able to manage the preview. And as you can guess already, the preview has nothing to do with the sidebar. They cohabitate, but they don't influence one another. And this is a problem in state machines in that case, because the machine can only be in one given state at a time. So there are several solutions. The easy one would be to create another machine only for the preview. But in that case, because we don't have that many states, that would be a little bit overkill. So instead, what we can do is to leverage one property of state charts, which are an extension of state machines. And these are parallel states. Parallel states allow us to have a fully orthogonal states, so states that don't have anything to do with one another, cohabitate within the same machine. So this is what we're going to do right now. So instead of setting everything at the root like that, we're going to say that our machine is of type parallel, like this. And we are going to move all of that within a parallel node. So we're going to say states. Within that, we're going to define our parallel state called sidebar. And we can move all this within it, right? So now that we've done that, we no longer need that namespace like we have here. So that's going to be much cleaner. So let's change that into expanded, here into collapsed, right? And so now we can also change it within the template. So here, instead of having sidebar collapsed, we can say sidebar collapsed like this. And here sidebar dot expanded like that. Let's move here, and I can still toggle. Great. So now we are ready to define our preview state. So let's do this. So in the same way, I'm going to create my parallel state called preview. I'm going to define an initial state. So for now, it's going to be empty. And then I'm going to define my states. So we will have visible and hidden, right? And so similarly, we can say visible has a transition on toggle preview. We're going to move on to hidden. And when we are on hidden, on toggle preview, we're going to move on to visible. So one small thing before we move on, because right now it might very well look like we are writing a bunch of code to change a binary state and that it would be much better with a Boolean. But the thing is that nothing prevents you from writing many more transitions. So for example, we could definitely say here that we have close preview, which would go to hidden as well. And here we could say open preview, which would go to visible. So here you can see that it's really easy to create many more transitions from one state to another depending on the current state. And instead of writing a bunch of new functions where you write imperative code, what you can do is declaratively write everything that your machine can do in all the states it can be in, all the transitions, and you have all that logic here at the state machine level in a way that is much easier to read. Let's remove this, and now let's refactor within our template. So we have here the toggle preview function being executed. So instead of that, we're gonna send an event. So it's gonna be toggle preview, right? And then we have a bunch of places where we are using this editor as preview open here. So you can see we are gonna select them all, and we are gonna move on to state.matches, and it's going to be preview.visible, right? So this should be good. And here you can see that it keeps on working. Perfect. So now let's move on to this part here, which is the preview mode. So HTML, rendered, etc. So we can affect that, but this is something that we want to only be able to change when the sidebar is visible. This is a state that depends on a parent piece of state. And so in Xstate, you can actually handle that with what we call hierarchical nodes or nested nodes, nested states. So let's see right now how to do that. So let's go to our machine. So here, instead of declaring another parallel state, what we're going to do is define a state, but within this visible node here. So we're going to do same thing, define an initial state. Let's keep it empty for now, and some states. So those are going to be child states. And so we can write our states like we are used to right now, you know, the drill. So HTML and rendered, right? So we would say that initially we are in rendered mode. And when you are in HTML, you can set a transition. So we could say toggle preview mode. And this would go to rendered, and on rendered, on toggle preview mode, we would go to HTML. And so this concept of nested nodes are actually creating compound states that we can use within our application. So we can go directly in our template to refactor. And so here, for example, at the end, you can see that we are doing a bunch of string equality checks like that. And so instead of doing that now, we can say state.matches preview visible HTML. Great. And so we have we have other pieces of code. So for example, here we are checking whether a preview is visible, and then if it's equal to HTML, what we can do instead is say directly .html, remove that, .rendered, remove this, Great. Let's not forget to get rid of that. So instead, we're going to send the event. So toggle preview mode. Great. So there should not be any remnants. No, that sounds fine. So we can remove a bunch of code, by the way. Let's remove all this. We can remove the toggle preview and toggle preview mode. This can go away as well, which means we can remove that, by the way. Let's remove this reactive object here. We no longer need to import reactive from Vue. And so now if I save and I go to my application, I am still able to move between preview and HTML. Now, there is one thing that I want to show you right now. We are on HTML, so this is not the default state. This is not the initial state. And if I move to HTML and I close the preview, then I reopen it, we are back on the rendered state. That's because the state machine does not remember what was the state that we were last in. And so that's something we want to fix. Xstate allows us to do that with what we call history nodes. Those history nodes are special nodes that you can set in your machine, and you're going to be able to remember the last state within a group of states. And so you're going to be able to transition back to that last memorized state. So it's pretty easy to do. What you're going to do is simply create a new state. So you can call it the way you want. I'm going to call mine memo and simply say it is of type history. And this is where we are going to persist the last state that we are in. And so when you are in hidden mode and you want to go back to visible, we are going to actually go to visible.memo. And instead of defaulting to the initial state, it's going to go back to our memo state if it's defined. So here, let's say we go back to HTML, we close, we reopen, and we are in our last memorized state. All right, so I hope you liked that demo. This was really only scratching the surface of Xstate, state machine, state charts. I know everybody always says that, oh, it's only scratching the surface, but I can guarantee you that it's true. You can do so much more with state machines, so I definitely encourage you to try it out. Try Xstate, try something else if you want. Like, to be honest, I don't get money every time that I mention Xstate. Maybe I should. The beautiful thing about state machines is that it's nothing new. That's a very old model, very tried and true pattern that backend folks have been using for quite a while. I would definitely recommend trying that out in front end. See if that can make your application better. I would encourage starting with something that would be at the periphery of your application. Don't necessarily start refactoring your entire application right away, the core of your application. Maybe you can start with something outside of it. Something like the login form, for example, could be a good idea to give it a test drive, see if you like it, see if your coworkers like it as well, see if it improves your code, if you can remove some tests that are actually covered in the library itself. All right, that's all for me, Vue community. Thanks for listening, and I hope we can see each other in the flesh very soon. Bye.